Problem 3, a thin, hollow, spherical plastic shell of radius r carries a uniformly distributed negative charge, negative q. A slice through the plastic shell is shown in the diagram. To the left of the spherical shell are 4 charges packed closely together as shown. The distance s is shown greatly enlarged for clarity. The distance between the center of the 4 charges to the center of the plastic shell is L, which is much larger than S. So for part A, calculate the net electric field at location B, a distance B to the right of the outer surface of the plastic shell. So the first step to calculate the net electric force at location B is to add up all of the electric forces at location B. So E net equals E shell plus E dipole from the parallel dipole plus E dipole from the perpendicular dipole. And the first step is to find R. And you find R by doing the observation location minus the source. So if you set your origin at the center of the dipoles, our observation location is L plus R plus B, 0, 0 minus the origin. So we get the vector R, and then we get the magnitude of R and the unit vector for R. And then we calculate E shell by the equation for the shell of a uniformly distributed charge on the shell, and that's the equation right there. And then for the E dipole parallel, we use the equation on the formula sheet for a parallel dipole to your observation location. And then for E dipole perpendicular, we do the same thing. We use the equation from the formula sheet, and this for the unit vector, it's negative because E net from the perpendicular dipole is pointing in the negative x direction. And then to find E net total, we just add them up in the x and y components, and the z component is 0. And so here are the values for the x and y components. For the next part, the plastic shell is removed and replaced by a solid neutral metal ball of radius r as seen in the diagram. The distance from the center of the 4 charges to the center of the plastic shell is L, which is much larger than S. And for part B, at location A, inside the metal ball, at distance B to the left of the outer surface of the ball, accurately draw and label the electric fields due to the collection of the 4 charges, E4, and the polarization of the ball, E ball. If any of these qualities are 0, please state this explicitly. So at location A, we have E4 pointing to the bottom right, and this is the net charge from the 2 dipoles. And then E ball is pointing in the opposite direction because inside the ball it's being polarized opposite to the net electric field from the 4 dipoles, or from the 2 sets of dipoles. And then so for part C on the diagram, show the charge distribution of the ball. So because E net from the dipoles is pointing to the bottom right, that means the neutral ball is going to polarize in this way. So the positive charges are going to be on the bottom right side of the ball, and then the negative charges are going to be on the top left of the ball, because this is how the ball is being polarized. And then for the part D, calculate the net electric field at location A. Briefly explain how you determine this. So at location A, it's inside the ball, and because the ball is metal, that means it's a conductor. And the net electric field inside a conductor is 0. So E net at location A is 0 because the ball is polarized in such a way that the polarized electric field is equal and opposite to the applied electric field. Thank you.